Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. Today we are going to discuss the next topic from the chapter uh, is matter around us pure. The title of this topic is what is solution? Yes, so title of the topic is what is solution. So in this topic we are going to discuss about the solution. Do you remember in the last class I have told you that the homogeneous mixture. In the last class we discussed about the mixtures. There are two types of mixtures, homogeneous and heterogeneous mixtures. The homogeneous mixture are also called as solutions. Right, are also called as solutions, right? Okay, now first of all we are going to discuss about the classification of solutions. The classification of solution is done on the basis of number of particles present in it, right? Okay, so sometime there will be 2 particles, sometime there will be 3 particles, or sometime there will be more than 3 particles, right? So on the basis of that, on the basis of number of components, on the basis of number of components, they are classified into different types. First example or first type is binary solutions. Bi stands for 2. So binary solutions will have one solute and one solvent, right? Okay, now what is solute and what is solvent, that also I will explain later. Second type of solution is the ternary solutions. Ternary solutions will have one solute plus 2 solvents, or 2 solute plus 1 solvent. Any combination we can have. Okay, and then the third type of the solution is the quaternary solution. In this also we will have different combinations like 1 solute plus 3 solvent, then 2 solute plus 2 solvents, then 3 solutes plus 1 solvent, like this, right? So we can have these many combinations here. So this is the classification of the solution based on the number of component present in it, right? Okay, so you can just take a screenshot of this page, guys, first of all. If you have any doubts in between, you can just write down it in the chat box. Okay, yes, so this is the first type of classification on the basis of number of particles. Now second type of or second classification we are going to discuss for the solutions. But now for the second time we are going to see the binary solutions only. Binary solutions, it will have only one type of one solute and another solvent, right? Before discussing that, I will tell you what is the meaning of solute and solvent. So these are the two components of the these are the two components of the solution, right? So solute is present in, it is present in lesser amount in the solution, whereas solvent, it is present in larger amount or quantity in the solution. Okay, for example, very simple example I can tell you here. For example, if I say the lemonade or the lemon juice simply. So in lemon juice there are two parts. One is the in lemon citric acid is present, so I'll write down citric acid, and another is the water, right? So water is present in excess larger amount, therefore water is solvent here, and citric acid or lemon juice, it is nothing but the solute here, which is present in the smaller quantity, right? Okay, so now this is about the solute and solvent. You can take a screenshot of this page first of all. Okay, yes, now on the base of this, the nature of solute and solvent, we are going to have the classification of the solution, right? Therefore we are going to discuss this classification for binary solutions, right? Because there is one solute and another solvent, and depending on the nature of them, we are going to have the classification. Okay, so I'll write down here the title, classification of binary solution. Binary solution has two components only. Solution on the basis of nature of solute and solvent. Nature, or you can write down your physical state as well. Okay, so here the type of the solution, okay, type of the solution. Then here, okay, here first of all I'll write down about solute, then solvent, then type of solution, and then examples. Okay, one by one we are going to discuss this thing. Okay, so first of all I'll keep the solvent constant, and that is solid. So in this case solute can be solid, liquid, or gas, right? So here let us see the names one by one. So if it is solid, both of them are solid, then it will be called as solid in solid. Okay, it is called as liquid in solid type of solutions, and then last one is called as gas in solid type of solutions, right? Examples for solid in solid: alloys. Okay, alloys means what? I'll tell you about alloys in detail later on. Alloys is a mixture of metals and non-metal solids. Then liquid in solid, the sugar solution, right? Sugar, what you can say, sugar solution, or anything you can write on: salt, water, sugar solution. Liquid in solid, just a minute, here I'll write down. Liquid in solid is nothing but the amalgam. What is amalgam? I'll explain later on. Okay, in amalgam the liquid is solute and solid is the solvent, right? Gas in solid. So in case of gas in solid, the H2 gas on platinum. PT stands for platinum, right? These examples, there is no need to remember all these examples. Just you need to understand the types of the solutions, right? Okay, then next I'll write down. Next is for liquid. Liquid is the solvent. It can be solid, liquid, and gas. So solid in liquid will be called as solid in liquid. I'll write down S for solid, L for liquid. Solid in liquid, liquid in liquid, and gas in liquid. Okay, so solid in liquid means the salt water or sugar solution in water. Okay, liquid in liquid means what? Alcohol plus water solution, or acetone plus water. Gas in liquid is the oxygen in water. You know, oxygen is present in water. The animals, aquatic animals, they take the oxygen, dissolved oxygen in water for their respiration, right? So these are the examples for this type of solution. Then the last type we can discuss, in which the solvent is gas. Solute can be solid, liquid, or gas, right? Solid in gas will be called as S in G, that is solid in gas, liquid in gas, and gas in gas, right? Solid in gas means, example for solid in gas is dust particle in air. Okay, then liquid in gas is water vapor or moisture in air. Moisture in air. Gas in gas, the air. Okay, air is the mixture of gases, mixture of different gases, right? So these are the examples for the different types of the solids. On the basis of what? On the basis of the physical state of the solid and solvent. You guys can just take a screenshot of this page. The classification of solutions. Just take a screenshot of this page. Just a minute. I'll just close my video so that you will be able to take the screenshot of whole page. Okay, I hope you have taken a screenshot of this page, and if you have any doubt in this, please let me know, so that we'll discuss that, and then we'll discuss the next part from this chapter, from this topic. So after the classification, we are going to discuss about the again the types of the solution, another type of the classification of the solution on the basis of the quantity or amount of solute present in it, right? Yes, so for that purpose I'll yes, let me write down the title first of all. Classification of solution, classification of binary solution only. Okay, binary containing only two components. Classification of binary solutions, binary solutions on the basis of amount of solute in the solution. Okay, yes, let us see that. Before discussing this, I'll explain one more thing here which is required to understand this classification, and that is nothing but the solubility, right? So what is the meaning of this word solubility? We usually use this word many times in our day-to-day life, right? For example, if I'm making a lemon juice, right, if I'm making a sherbet, so in that case what I do, I take the water, desired amount of water I take, I'll add lemon juice to it, I add sugar to it, and then I mix it, right? When I'm mixing it, what happens? The lemon juice and or lemon extract and sugar crystals get dissolved in it, right? So what do we say? That is, sugar is soluble in water. What word we use here? Sugar is soluble in water. So what is the meaning of that soluble? Solubility is nothing but like the substance is getting dissolved in water, right? Some substance is getting dissolved in water, that is nothing but the solubility. Okay, now on the basis of the solubility, different substances have different solubility, right? If I try to I take different solvents, like one I take water, another I take alcohol, and third I take what you can say acetone, right? So if I try to solubilize or dissolve the same substance in these three solvents, like if I try to dissolve sugar in all these three, obviously their capacities are different. All of these three will solubilize these components differently, right? If I am comparing their solubilities, the solubility of sugar in water will be maximum as compared to the others, right? Okay, so this is nothing but the solubility. Solubility is the property of getting dissolved in the solvent, right? So that is nothing but the solubility. On the basis of solubility of the substances, there are three types of the solutions, right? Okay, so first of all, I'll write down the three types and then we will discuss them in detail. So first is the unsaturated solution. I will explain them later on in detail. Let me first of all write them: unsaturated solutions. Second type is the saturated solutions. And the third type is the supersaturated solutions. Okay, third type is the super saturated solutions. So these are the types of the solutions I am going to explain now. Super saturated solutions. Okay, for that purpose I will just explain one simple experiment to you. Okay, we are going to perform we can perform this experiment at home as well, right? What we are going to do, we are going to take three vessels, or you can take three glasses also, you can take any three vessels, right? So as this is an experiment of chemistry, I will use the word beaker, right? You can take test tube also, it's not necessary you should take beaker only. So this is the first beaker. Okay, you can take test tubes or you can take any kind of vessels, right? Okay, so this is the beaker A, you can say this is the beaker A. So the second beaker I am taking, you can take test tubes, you can take volumetric flask, whatever you want. Okay, this is the beaker B. And then last, okay, this is the beaker C. So these are the three beakers I am taking. Okay, you can take any vessel, it's not at all restricted. So in this beaker I am going to add the same amount of solvent which I am taking here. I'll write down that part first of all here. So here I am taking the solute as a salt, NaCl salt. Solute is NaCl and solvent is H2O, that is water. Solvent is H2O, that is water. Okay, now here I am going to keep the amount of water fixed. Okay, in all of them I am going to keep the amount of water fixed. So this is the level of water in all of them, it's constant. Level of water in all of them, it is constant. So this is the water, the same amount of water I am going to take in all of them. The quantity of solvent I am keeping fixed, right? So I'll write down that part here. I am going to take for an example 20 ml of water. Okay, I am going to take for an example 20 ml of water, right? I am going to change the amount of sugar crystal in them, right? I am going to change the amount of sugar crystal in them. For an example, in this I'll take for an example in this I'll take 1 gram of sugar. Okay, I'll take 1 gram of sugar. In this I'll take 5 gram of sugar. Or here instead of 1 gram, just a minute, here I'll take 0.1 gram of sugar. 0.1 gram of sugar. Here I'll take 2 gram of sugar. 2 gram of sugar. And here I'll take 10 gram of sugar, right? 10 gram or 5 gram I'll write down. Here I'll take 5 gram of sugar, right? Okay, now I'm going to ask one question to you, simple question. Now the image is the whole image will be visible to you. Just give me a second. Okay, this is the small experiment we are going to discuss. Okay, yes. Yes, so just observe this image carefully and answer some questions which I am asking to you. Right? If I say the capacity of this 20 ml of water, you know, every water, like if we change the volume, its capacities to dissolve the solute in it different, right? For an example, if I am taking a full glass of water, I can add 1 or 2 teaspoon of the sugar in it, it will dissolve. But if I take half or less than half amount of water in it, and if I try to dissolve the same amount of sugar, is it possible? No. That means obviously on the base of volume also the solubility is changing, right? Assume that the solubility of 20 ml of water is to dissolve 2 gram of sugar in it. 2 gram of sugar is its capacity, right? What is its capacity? It can dissolve 2 gram of sugar in it very easily, right? It can dissolve 2 gram of sugar very easily, right? So first of all, if I am talking about 2 gram of sugar, so 2 gram is its capacity. Its capacity is fulfilled, right? It is not at all expecting more sugar molecules, or it is not at all having extra sugar molecules in this solution, right? Right, it is up to the mark, it's it until its capacity only, right? Therefore this solution present in the beaker B is called as the saturated solution, right? Saturated means what? Saturation means what? That is up to its capacity. Saturation is the up to the capacity only, right? Okay, that means in saturated solution which is present in beaker B, we cannot add the more sugar molecules further, right? Because it is saturated. If we add further sugar molecules to it, they will not get dissolved, right? They will not get dissolved. So that is the saturated solution. Saturated solution has exactly same amount of solute, that is its capacity, right? Okay, now that is about the sugar solution present in beaker B. What about the first beaker A, beaker A? In case of beaker A, you can see capacity is 2 gram, amount of water is same 20 ml, capacity is 2 gram, but there are only 0.1 gram of sugar, right? There are only 0.1 gram of sugar. That means we can add more and more sugar molecules further to it, and they will get dissolved unless and until we are reaching the amount up to 2 gram, right? So that means in case of 0.1 gram of sugar, there are less molecules of sugar present in the beaker as compared to or than the required amount. Therefore, this is called as unsaturated solution. Un means not. It is not saturated. Unsaturated means not saturated, right? So beaker A contains unsaturated solution, right? Beaker A contains unsaturated solution. Okay, then we'll discuss about the last one. In the last one, you can see capacity is 2 gram, but there are 5 gram of sugar, right? There are 5 gram of sugar. Even if we forcefully try to dissolve the extra 3 gram of sugar in it, will they get dissolved? No, because their capacity is 2 gram only. After 2 gram, even if you try to add dissolve single molecule of sugar, it will not get dissolved, right? Therefore, it has extra molecules of sugar. Those extra molecules of sugar, they will get saturated or deposited here, right? Those extra molecules you can see, the extra molecules of sugar you can see at the bottom. Just like you see when we are making the sugar solution, in that case also if we add the extra sugar, then that sugar crystals will remain at the bottom, right? And then we add some water and it get dissolved, right? Okay. Now, in case of the last type, therefore, this is called as the super saturated solution. This is called as therefore super saturated. Super means what? Above the saturation, more than saturation. This is called as super saturated solution. So, therefore, these are the 3 types of the solutions. Okay. First of all, you guys can just take a screenshot of this page, that is classification on the basis of the amount of the solute in the solution, and then I'll just close the video for that purpose, and then you can just we'll discuss the, or we'll have a quick recap of whatever we have discussed right now. You just take a screenshot of this page. I hope you have taken a screenshot. Yes, now let us discuss whatever we have studied in today's session in brief. So today we have discussed the topic called as what is solution. In this we have discussed the homogeneous mixture is nothing but a solution. The number of components, on the base of number of component, there are two different types of the solutions, like binary solutions, two components, one solid one solvent, ternary, three component, quaternary, four components, right? Yes, this was a classification based on the number of particles or components. Next was, we have learned that is solute is present in the lesser amount or quantity, solvent is present in the larger quantity in the solution. For example, in case of sugar syrup, I will give you sugar solution example. Sugar will be solute, water will be solvent. On the basis of nature of the or physical state of the solute and solvent, there are different types of the solutions which I have listed over here. That is, solid and solvent can be solid, liquid and gases. Some examples we have seen over here. Then we have seen the classification of binary solution on the basis of amount of solute in the solution. So we have learnt about solubility. The three types are unsaturated, saturated and supersaturated solutions. So we have seen one experiment in which NaCl is the solute and water is solvent. I have taken a fixed amount of water, that is 20 ml. Always remember, like when you dissolve sugar in water or salt in water, are the water are the sugar molecules visible inside that solution? No, when they are dissolved, that is the homogeneous mixture. Homogeneous mixture means the solid particles, the solid crystals will not be visible there, right? Therefore, in beaker A and B, in which there is 0.1 gram, that is lesser than capacity, and 2 gram, that is up to the capacity, therefore sugar molecules are not visible. But if we try to add more amount of sugar molecules to it, they will be settled at the bottom. We can see the solid crystals which are not dissolved in the solution. So this is called as the supersaturated solution. 0.1 or less than capacity is unsaturated, and up to the capacity is the saturated solution. So these are the three types of the solutions which we have learnt in today's class. Okay, so that's all for today, guys. From the chapter atoms is the matter surround us pure. We are in tomorrow's session, we are going to discuss next topic from the same chapter. I hope you understood this, and if you have any questions, please let me know, and I'll show you how to upload this DPP on the portal. So you can see this is a teacher's portal. So similar will be for the student. You can go to resources, then the writing material. In the writing material, you can see DPP daily practice problem will be available in the form of PDF. You can download it here, you can solve it, you can take a picture of it, and you can just upload on your portal. So that will be visible to me here in the actions. After reviewing your questions, I will evaluate them and let you know about suggestions wherever required or corrections, and then you can work on those. Okay, so that was about DPP daily practice problems. And then yes, so that's all for today, guys. Thank you so much for your precious time, and all the best to you. We are going to discuss in today's session, tomorrow's session, we are going to discuss about the suspensions and colloidal solutions. Thank you so much, and bye bye, take care.